True, false quiz. Determine whether the statement is true or false. If it is true, explain why. If it is false, explain why or give an example that disproves the statement. Alright, so let's take a look at question 1. This one states, if the vector u has components u1 and u2, and the vector v has components v1 and v2, then the dot product u dot v is equal to u1 times v1, and then the next component is u2 v2. Well, this is a vector, and the dot product is actually, the dot product is a scalar, so this is actually just false right off the bat. So false, this is false. The dot product is a scalar and not a vector. So in other words, you would get rid of these brackets, get rid of this comma, and just put a plus. So that is what the dot product is. So here's the definition of a dot product. So it's a scalar and not a vector, and it's for recall from earlier video. Here's the link to it. So the dot product definition, if you have the vector A and vector B, A dot B, you take the components, multiply them, and then you add each corresponding multiple of the components. So you don't actually make a vector like this. It's not a vector, it's a scalar. So you add these up, you get a number. Alright, so now let's jump right into question 2. So for any vectors u and v in V3, this is just basically the set of all real numbers in 3D. Yeah, basically a set of all numbers with 3 components there. So yeah, just in 3D. So you have, so this, we're given this right here, and see if this is true or false. So the length or the magnitude right here, that's with this opposite value sign, of the vector u plus v is equal to each of the u and v magnitudes or lengths added separately like that. So then this is actually, well, false, and I'll show you why it's false. So consider the following example. So let's say we had, we're going to do an example to show you that it's not true. So let's just say we had u is equal to 1, 0, 0 vector. So just a unit vector like that. And let's say we had a v is equal to like this. This is u 0, 1, 0. And now the reason for this is, well, if you take the absolute value, or I mean the length of each separately, it's going to be 1. Add them up, it should be 2. Except in 3D, these are the components. So you're going to get a triangle in the 3D Pythagorean theorem. Yeah, for the distance formula, and that's just basically a square root 2. So basically, if we do this, if you do the distance formula, u plus v, like this. Yeah, this right here, this equals to, well, let's just add these up first. So this equals to, well, 1 plus 0 is going to be 1. 0 plus 1, so we just add the components, is 1. And then 0 plus 0 is 0. Like this. And now this is going to be, we're taking the distance of it. And recall distance formula is just going to equal to, yeah, it's just a Pythagorean theorem in 3D. So this equals 2, this is going to be this squared, 1 squared, and then plus this 1 squared, and then plus the 0 squared. This just equals to, well, 1 squared is 1, this is 1, that's 0, so square root, and these add up, is square root 2. So that is the thing, yeah, it's plus or minus square root 2, but yeah, but we're only dealing with the positive. I always put a plus or minus when we're dealing with square roots. But nonetheless, anyways, we stick with this right here. So that's going to be square root 2 like that. But yeah, but if we have it separately, like this plus this right here, v, the distance or the length of v plus the length of u, this equals 2. Well, again, Pythagorean theorem for each one separately. So u is, and here I'll just rearrange this because we had u first. So u and v. So u is 1, 0, 0. So that's going to be 1 squared is just 1 plus 0 plus 0. And then this is going to be, well, plus v, length of that is going to be 0 squared plus 1 squared, yeah, plus 0 squared. This equals 2. This is just going to be square root. Yeah, this is all just going to be 1. And the square root of 1 is just 1. This one's going to be 1. So 1 plus 1 is 2. Yeah, so that's 1 plus 1 is 2. Yeah, now we have a problem right here. So this is square root 2. This is 2. So this is, well, not equal to. So they are not. So yeah, this is false then. Yeah, so this is false statement. Yeah, so just type it out. So hence the statement is false. All right. So now let's take a look at question 3. So for any vectors u and v in V3, so again, the set of all numbers in 3D, So we have the statement, the magnitude or the distance, the magnitude u dot v is equal to the magnitude u multiplied by the magnitude v. So this is actually false, and we'll go over that. So here, look at the solution. So this is false, and the reason is this is just a dot product geometric formula, but there should be a cosine there. So this is false, as the formula needs a cosine function. So recall the geometric formula for the dot product. This is shown below from my earlier video. Here's just the thumbnail I made for that section's video. So the dot product, so the a dot b is equal to the magnitude a times the magnitude of b times cosine theta, and here's geometric interpretation of that. So this is the angle between a and b there, and that is included in this dot product. So the dot product has that cosine in the dot product for this geometric proof there, and so thus the magnitude of the dot product would be, because if we're doing the magnitude right here, this is a magnitude, this is just the formula without the magnitude. If we take the magnitude, all we're going to do is just, well, this is already a magnitude of these. The magnitude is always going to be positive, so we just take the cosine, the positive value of that, so the absolute value of that. So the magnitude of u dot v is equal to magnitude of u times magnitude of v times by the magnitude of cosine theta. In other words, the absolute value of cosine theta, because this could be negative at the angle. Because the function could be negative for greater than 90 degrees and so on. Alright, so now let's take a look at question 4. So for any vectors u and v in V3, or basically again the set of all numbers in 3D, if we have the magnitude of the cross product u cross v, and we're told that this equals to the magnitude u times by the magnitude v. So now this is actually false, and again the reason is because we already have the formula for the length of a cross product, or the magnitude of a cross product. So the solution is false. So this is false. The length of the cross product formula has a sine function in it. Yeah, so function in it, yeah. So this is missing the sine function right here. So this note from my earlier video is a thumbnail for the cross product a cross b. The length of it, the magnitude, is equal to the magnitude of a times magnitude of b, or the length of a and b, and multiplied by each other times by sine theta. So, and this is the length of it from this bottom part to the top, and that has a sine theta. However, for perpendicular vectors, then the formula would be true. Yeah, so for perpendicular vectors, the formula, this one right here, would be true, and that's because if they are perpendicular, then theta is equal to 90 degrees. So what we'll have is u cross v, this would equals to, for perpendicular vectors, this would be equals to u, and then v, and then sine 90 degrees. 90 degrees, if we recall, that just equals to 1. And you could recall right here the sine function. Just to recap, I always do this. So there's a sine function. This right here is sine theta. This is theta, and this is at 90 degrees. 90 degrees, or pi over 2, and this is just 1, like that. So there's 1. So then, so that's perpendicular 90 degrees, and put the origin like that. And so in other words, this equals to u v, like that. Yeah, u times v. So this would be true in this scenario right here, and I'll just put like this, cross v. This is only, if it's for perpendicular vectors, then that is true. But in general, this is false.